The present problem considered here is the third problem in the set of problems on two-port networks, and it's on ABCD parameters, and we read out the problem. This of GATE 2006 for 1 mark and for two-port networks. Now problem is a two-port network is represented by ABCD parameters given by V1 I1 ABCD over V2 minus I2, and if port 2 is terminated by RL, the input impedance seen at port 1 is given by and these are the various options. We have to find the input impedance seen at port 1. Okay, now solution to this problem is we have redrawn this two-port network here, and I1 V1 correspond to the port 1 and the I2 V2 are the currents and voltages at port 2, and the port 2 is terminated by resistance RL. So we notice the ABCD parameters are also said to be a transmission parameters, and one very important feature of these ABCD matrices or ABCD parameters is that here V1 I1 at one port are related to V2 and I2 at the other ports, because you can see here V1, this relation is given V1, and this is in terms of the parameters at the output port. Similarly, this is I1 parameters at the output voltage, output port or second port voltage and currents. So it has a very important property of cascading. Those two networks can be easily cascaded. Okay, so anyway, this is the governing equation for ABCD parameter, and here we notice that minus I2 is the current flowing out of the port 2. Normally this current, most of the parameters which you have considered, the current has been entering into the port, but in these ABCD parameters we take a current coming out of the port, so that this current also enters the next cascaded network. That's why it's taken the other way. So anyway, we can write I2 is the current flowing through the port, so we can write V2 minus I2 into RL. You can see from here I2 knowing into direction of the current flow, we can find V2 is minus I2 RL, and input impedance should be given by V1 over I1. So V1, what is V1? We know the value for V1 here. This is V1 and this is the value for I1. So AV2 minus VI2, CV2 minus DI2. So this is the equation. Now substitute for V2, we have to minus I2 RL, substitute for V2, that is minus I2 RL, and then minus I2 RL minus us, you get the equation of this kind, that is ARL plus V divided CRL plus D. So this is the input impedance for this network, two-port network, when it is terminated by the load RL, and this corresponds to option D. You can observe here that this is corresponding to option D here. So option D is the right choice here for this problem. Okay, thank you.